Testing, 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 2, 3, 4, 5. Oh, I think I had something muted. Whoopsie daisy. Haha. Okay, whoops, sorry about that. Oh my goodness, how embarrassing. How unprofessional. Okay, so I've just been talking to myself for the past 5 minutes. That's always fun, right? So, yeah, wow, I can't believe chat's active already. You guys found me quick. Pavel, you said you're from Kiev? Wow, that's really far away. I hear it's nice though. Um, yeah, so I'm trying something a little bit different this time. Streaming wise, I'm actually streaming without my GPU at the moment. I'm using the X264 codec, which is CPU based, and I'm doing that because I want to see if see on the last stream I was using my GPU for streaming, and it really made my gaming kind of not so good. So I want to see if I can split them apart. I'll do my streaming on the CPU. I'll do maybe some gaming later on the GPU. How about that? Oh, it might work. Anyway, if you're wondering what we're doing here, what I'm building, this is a old version of Mesa. Mesa is for 3D graphics. 3D. It's mostly for like accelerated graphics, right? Um, but this old version of Mesa actually was ported for the Cell CPU of the PlayStation 3. So that's where we're building it on the PS3, and it's gonna take a little while. It's not a small package, so let's put that up there. I said it's not a small package. Yeah, Mesa on the cell. It uses the SPUs, the accelerators. AV1. I'm not so familiar with AV1. That's another. Is that hardware based? Oh, hey, Math Mage, how's it going? Yeah, I'm streaming on my older laptop, my Gen 2 machine. Um, yeah, and it came with a bunch of demos, so I'm going to show you guys some of the demos of 3D graphics running off the cell SPUs. Oh, well, the machine that I'm streaming from right now is this is my old HP Envy. Um, it's still got some good power. My Gen 2 laptop right here. Uh, yeah, see, Ryzen 5 12 core. It's only got 8 GB of RAM though, which is kind of small. Oh no, Asus Celeron. Yeah, the Celerons weren't so good, right? Oh, you got a ThinkPad. Everybody seems to like the ThinkPads. They're very popular. But yeah, I mean, when I was, you know what happened was I downloaded my previous stream from YouTube, and I was doing some editing with it, you know, and watching it over, I noticed how bad the RPCS3 was, my FPS was dropped down really low. So I thought of this experiment to try. I'll try streaming from the CPU instead. And we'll free up the GPU. Um, oh hell yeah, Math Mage. That sounds elaborate. I do kind of have a dual PC setup. I've got two laptops here, but I use one of them to monitor to try to monitor my audio. Um, oh hell yeah, Black Mesa. That's a Valve game. It's Half-Life. That's a pretty cool game. Hey chef, you're running Fedora? That's what I run on my other laptop. I got the um I got Fedora on my other laptop and I got it on my desktop rig too. But nope, on this one it's Gen 2. Yeah, I wish this computer had more RAM. It could use it. It could actually use a bigger hard drive too, because the hard drive on this machine is shit. I think 200 some odd gigabytes. It's not very large. Oh, Black Mesa is made by fans. That's interesting. It's a remake. I wonder if I have that. I have like a couple of uh Half-Life titles. Oops, that's Discord. Let's do this. Yeah, I got Half-Life. This one, Half-Life 2, Half-Life Deathmatch, another Deathmatch. Oh, you like Black Mesa better? Huh, I'll have to check that out. Check it out. You could see the build here for Mesa. It's running this is PPU 32 GCC. That comes with the software development kit for the cell. That's where that's from. That's where that program is. It comes with the PPU GCC programs and the SPU GCC programs. Oh yeah, like X264, like if you run it from the command line. Yeah, it's got um a lot of options. Oh really? You can offload the GPU, huh? Let's see. Yeah, let me show you what I was working on earlier today. I've been kind of going over the tutorial examples for that are in the documentation for the cell, and oh yeah, that's right. Yeah, I never do though. I never add any flags to the encoder. I should probably look into that, see what kind of mischief I could get up to by customizing my X264 command line. I'm still trying to figure out a good equalization, like equalizer option for my audio. I do use a compressor, like a software compressor, but I think an equalizer would be good. Well, I just think it'll fun to see if my maybe if I try to run RPCS3 again later on, see if it runs a little bit less choppy than it did last time, because my frame rate during Resistance Fall of Man dropped so low it was just unplayable, you know. Um, so yeah, what I've kind of been doing today and like these past like yesterday and stuff is kind of going over these cell tutorials. Um, you can find this on my website, by the way. This documentation. I'm hosting it. Let's see. Um, I'm gonna I made a directory called PS3 Cell Tutorial. I may just put I may put this on GitHub too. Um, so that there's a convenient place for people to go look for the cell tutorial source code. I don't think it's on GitHub right now, so I might put it there. Anyway, I'm still in the first chapter here. SIMD basics. SIMD is single instruction, multiple data. Oh, huh, that's interesting. So it can start digesting. Yeah, the servers that you upload to for YouTube and like Twitch and everything, they're called digest servers for some reason. And so far, I've done two of the example, like tutorial examples. The first one demonstrates a AltaVec instruction called vec add, which adds two vectors. It's just a demonstration of like what a SIMD instruction looks like, or a SIMD function looks like. And then I added this myself, the make file. This is not from the tutorial. I made that myself. Oh, Alpine Linux. Yeah, I've heard about that. That's a very lightweight distro, right? Very minimal. What kind of package manager does Alpine use? Is it RPM or is it Debian based? I'm partial to the RPM distros myself. And this is the vector add program, and it's very simple. Excuse me. All it does is here it makes these integer arrays, integer like these arrays of 4 integers here, and this directive tells the compiler to align the data on 16 byte boundaries. SIMD operations like to have their data aligned in memory. And then we just initialize 2 of them and leave the third one uninitialized. Let's see. Declare some pointers here, and then assign them with the addresses of our arrays. This is a cast right here, and then right here, this is the vector add function. This is a AltiVec function. Uses special AltiVec registers. And then we just print out the results of the addition. Very simple little dumb program, just to show you what a SIMD function looks like. And when you run it, oh, gotta build it first. Okay, and when you run it, that's what you get. Very simple little program. This is another SIMD demonstration. Oh, cool! Check it out. Our thing is done building. Our Mesa is done building. Okay. Let me see if I can remember this right. I need to export a environment variable. LD library path. pwd slash I think it's libgallium. And pwd slash lib. Okay, cool, Math Mage. Hey, it was good to see you again. Let's see. All right, now these are all the demos for the 3D whatchamacallit, you know, Gallium 3D Mesa, and they should be configured to run on the cells SPU. So just to double check, I'll just open up a terminal here and log into the PlayStation. I'm gonna run SPU top, and that is the top program that monitors my SPU cores. As you can see, there's nothing going on right now. They're not doing anything. And we'll see if they start. We'll see if we can make them wake up. Not open display. Oh. Oh, I think that may be because I'm running over SSH. Oh, you know what? Shit, I forgot to do I'm trying to do X over SSH right now. I have to re-sign in, but I have to use the Y option. Okay. There we are. Now it's doing it. Check it out. There they go. Please save this link. Oh yeah, I've been doing that. I've been leaving my live streams up because they don't seem to, they haven't been like such like throwaway kind of streams, you know. Yeah, there's my now you can see there my SPU cores. I've got 1, 2, 3, 4, 5, 6 SPU threads going. That's one thread per SPU. And it's making this toroid shape. That's called a toroid, by the way. It's not a donut. Seven watching and only one like. Meth Mage is funny. Yeah, there's these little commands here that I can throw out at it. Let's see. And put it always on top. Let's see. I can make it I can change the shape to a sphere, I think. All right. Oh, maybe not. Oh, whoopsie, it's not taking my commands. That's okay. Um, the support for the cell CPU is really just kind of experimental at this point. It was never really finished. Um, Pretty much all it's good for is just running these little demos. No, no, I'm not too familiar with the PS4s or the PS5s. I don't own any of those. Just the just a couple PS3s. Oh, whoopsie, I crashed it. Whoopsie daisy. Close that window. Did I finish what? Oh, am I adding cell support to Mesa? No, no, no. I'm just demoing a very old version of Mesa that happens to have experimental cell support on there. Yeah, graphics programming on the SPUs. Well, programming in general is probably a little bit over my head. As a matter of fact, I'm positive it is. I'm not, I'm not a real C programmer. I'm getting there though. I'm getting better. You know, I mean, that's kind of the whole reason why that's the whole reason why I fuck with the PlayStation 3 and the Cell CPU, because you don't get better except by doing things that are too hard for you, right? You have to bite off more than you can chew in order to improve, right? I've always kind of been that way. Ah, damn it. Ooh, that's barely moving. Wonder why it's going so slow. I guess it's because it's over the network. This window is displaying. Wow, 2 frames a second. It shouldn't be going that slow. It's crazy. I tried a different one. Yeah. I don't know. Maybe my streaming is taking up all my network traffic, because these aren't running too good. They usually run better. I wonder. Yeah, that's a bouncing ball. Um. Oh, no wonder they're running like shit. That Vow demo is still running. I thought it crashed. Oh, it's still running? I gotta kill it. That's the problem. Oh, there we go. I think I got it. I forgot to kill that process. Well, yeah, adding cell support to the Mesa libraries. I mean, it would be nice if somebody would would look into it, but uh, it's definitely a little bit above my head. You know what I mean? Pavel, I'm not too familiar with any other Linux distributions that still support PowerPC 64, big endian like the PS3 is. Um, I know that Fedora supported this architecture all the way up until there we go. Now it's gonna work better. Yeah, that's my engine. Um, yeah, if you're looking for something modern, Gen 2, like I'm gonna say for now, Gen 2 is probably your best bet. If you need something that's like bleeding edge, uh, I'm pretty sure that you can still use T2 Linux also, but that's another meta distribution. That's another one that you build from source. It's not a binary distro like Fedora. You can put Fedora 28 on PS3. I actually have it installed on one of my partitions. I could boot into it and show it to you if you like. It's way more modern than the Fedora 12 that I'm using right now. It's requires a lot less updating to make it useful. Oh yeah, yeah. If you want to text me on Discord, yeah, feel free. It might sometimes it takes me a long time to answer, but that's because I'm absent-minded. Oh, that sucks. Sorry to hear that. Pre-baked. I'm not sure. I'm not sure what that means. Pre-baked. Um. Oh, yeah, yep, pre-built. Well, there's just not too many modern distros that still support the PowerPC 64. Um, I had a viewer here the other day that was we were actually he was actually finding some modern distros that like I'd never even heard of before that still work for the PowerPC. And I guess you could use one of those, but you'd still have to kind of assemble this like a stage 4 tarball yourself. That's kind of how we installed them. Um, okay, yeah, like you would take something like a Void Linux, like let's see if they offer like a stage 3. Um, when I say a stage 3, what I mean is if they offer like a pre-built file system that you can um, unarchive basically onto a blank partition, and then all it's missing is a kernel. So if you could build your own kernel, you can boot that file. You can boot into that file system. That's what a stage 3 is, more or less. See, void packages. Wow, 750. Yeah, that's what the PS3 is right there. That's actually the PS3 CPU is binary compatible with that specific PowerPC 750. Oh no, I'm wrong. I meant to say 970. Shit. Anyway. Hmm. Well, yeah, I don't know about the script. This is meant to build a bootable image, but I promise you, whatever it builds, it won't boot on the PS3. I need like a stage 3 tarball. Maybe I could just type in stage 3. um, you mean in like active development? Probably not. No, PowerPC is kind of a forgotten architecture at this point. um, it's being dropped by more you know, by more projects than it's being like maintained for. You know what I mean? Well, I wonder what their installation guide looks like. Um, Shaders. Well, I guess I can't really speak to that with too much authority because I've never you know, I've never written like shader software. But I do know that those workloads can be parallelized, you know what I mean? Which is kind of the name of the game when you're working on the PlayStation 3. So yeah, there's some demos of some programs that run on the SPU cores. So just so you can see it, they do work. You know, they spend they spend almost all their entire lives like idle, not doing anything, but they do still work. Another one of my tutorial programs that I made today was this one here. Uses the SIMD function vec_perm. Perm stands for permutation. Basically, yeah, what this does is it this transposes a matrix. Basically, if you've ever taken linear algebra, and then you know what a matrix is, right? And then you take like a 4x4 matrix and you can transpose it. It's basically just a algorithmic way of rearranging the elements of the matrix. Here, maybe I can find a YouTube video. Did I just see Danny DeVito as a mermaid? Or am I just too stoned? I guess it could be either. Well, yes, there were some supercomputers that were built that were PS3 based, and you know, there was some other ones that used the cell CPU that weren't PS3s. They used IBM Blade servers. I'm not gonna watch the Khan Academy. They'll take down my video. How about I need one that's short. This looks short. Okay. The matrix has n by n dimensions. The transpose of that matrix will have n by n dimensions. We don't gotta worry about that because we're working with a square matrix. What's wrong with PowerPC architecture? It's just old. Yeah. If you see PowerPCs in anything these days, you mostly see them in like routers, you know, that kinds of thing. Yeah, Apple developed it for a while. As a matter of fact, the registers, the AltaVec registers, that's an Apple technology. I think they introduced that to PowerPC for like, you know, multimedia processing, you know, images and video. That's what the AltaVec was for. And they work by doing SIMD. Let's see. Wow, Cowan Academy, your math video is boring. Where's the music? Where's the pizzazz? I'm not hearing anything. I should give you a thumbs down. Here we go. Transpose of a matrix. Linear algebra, 7 minutes. All right,
An
we'll learn
important
something.
matrix operation, which we'll see many uses for as we progress through this course, is the transpose of a matrix. The transpose of a matrix A is denoted AT, so we put that
AT.
T in the superscript, and it's the matrix whose columns are the successive rows of the matrix A. So to find A transpose, we simply swap the rows and columns. In this video, we'll talk about this definition, go over some examples, and some...
Have I used it? Oh, well, yeah, many years ago. Yeah, a couple of years, like years ago, before I first jailbroke this PS3. I did used to use it for gaming, but I've never been a huge. I've never, like, for the 7th generation, I was not a huge gamer because I spent more time like doing homework and stuff. Um, I mostly use this PS3 as a Netflix machine, actually, uh, more than gaming. But actually, and nowadays I actually have a second PS3, and I use that one for gaming. And I have my old one for running Linux.
interesting properties of the transpose. Here's what it looks like with an arbitrary example. This is a matrix A. Its dimensions are m by n. It has m rows and n columns. To find A transpose, the rows of A will now play the role of the columns of A transpose. So you see this first row of A, A11, A12, all the way up through A1n. It's precisely those entries which make up the first column of A transpose.
Get what he's saying? The transpose of a matrix is just it's a reorganization of the elements, by a certain algorithm, by a certain pattern, you might say. That's foreshadowing, by the way.
This first row has become the first column, A11, A12, all the way up through A1n. And of course, this transpose has
Ray triangle intersections. You're gonna have to refresh my memory, my friend, Danny Lou. It's been a little while since my linear algebra classes. Ray triangle intersections, is that implemented through matrices? Is that matrix math?
dimensions n by m, so it's like the reverse of A in terms of the dimensions. You can see how the second row of A is the second column of A transpose. We could also talk about this the other way around. So for example, we notice the first column of A is the first row of A transpose.
And
the second column
I'm gonna give this guy a thumbs up because he deserves a thumbs up.
Of A is the second row of A transpose. So we can say that the rows of A become the columns of A transpose. We could also say the column.
Oh, well, if it's vector manipulation, if it's vector math, then there's got to be a way to implement it on the cell, because that's vectors is like what it's good at working with. It's you have to I mean, when you're like doing performance, like tweaking on your cell programs, yeah, you're gonna be doing a lot of parallelizing and vectorization of everything that you can mathematically.
Columns of A become the rows of A transpose. You could also think of it like this. If A transpose is a matrix B, then the entry in row I and column J of B is the entry in row J and column I of A. Here are 4 examples. You can pause the video and try them yourself, finding the transpose of each matrix before watching on. Let's go over the solutions now. The matrix A has a single column. To find A transpose, that single column becomes the single row. You could also think of it as A having 2 rows, and so each of those rows becomes a column in A transpose. Now, what about B and B transpose? To find B transpose, we take the rows of B and use those to construct the columns of B transpose, which looks like that. You can see this first row as the first column. You can see this
Second row becomes the second column, and then the third row becomes the third column. Cool, right? Now we're going to implement this using C, and we're going to do it using SIMD functions.
second column, for example, as the second row. You can see this third row as the third column. The rows and columns have swapped. That's how we find B transpose. Now, what about C? Well, C is 3 by 2, so C transpose will be 2 by 3, and we'll have C's rows as its columns. And it looks like that. There's a row, and it's a column in C transpose. Second row, second column.
Well,
Third
actually,
row,
believe it or
third
not, I
column.
finally got my hands
Last
on
example, matrix D. Let's find its
Shit.
transpose.
I finally got my hands on a digital download of The Last of Us. I actually bought it on my PS3 account. You can still technically buy games that way online. So yeah, I bought it from Sony and downloaded it on the PS3. I've only gotten like an hour or two into it. I haven't gotten that far. The Last of Us is actually kind of hard. I find it harder than Uncharted. I still haven't seen any of the newer Gods of War. I've only played the older Gods of War games with the like the quick time events and stuff like that. The old school games. Yeah, so that's what this program here gives you, the transpose of a matrix. Basically, that's what this is. This is for some reason they decided to define this this quote unquote matrix as an array, which all matrices are arrays basically in memory on a computer. But notation wise, they could have broken this up into rows and columns. I don't know why they didn't do that. So yeah, they defined this like array of 16 elements, and that represents our matrix that we want to transpose. So at the end of the day, we're going to end up with this line here, 1, 2, 3, 4 is going to end up vertical, 1, 2, 3, 4. 5, 6, 7, 8 is going to be in the second spot. 9, 10, 11, 12 is going to be in the third column. And the last one becomes the last column. And then we define another array here to hold the result matrix. It's A capital T for transpose. This is just a function that will print out a matrix that if you send it the matrix as an argument, as a parameter, it accepts the matrix as a parameter. And it prints it out. Let's see. Oh, hey, you like Uncharted? I might play some Uncharted tonight too. I tried playing it on stream last time, but I got up to the Jeep chase in Uncharted 4, where the military truck was shooting at me, and the game crashed. It froze on me. So to do the transposition of this matrix, we do it in two parts, this part and then the bottom part. And in the middle, we print out, the results of transform 1 and then the results of transform 2. And we're using this AltiVec function a vec underscore perm. Perm stands for permutation. This is a SIMD. SIMD function. And then we print out the final matrix at the end. And to build it, you can use my make file that I created. Just run make, and then you can run it. And there it goes. 1, 2, 3, 4 ends up 1, 2, 3, 4. 5, 6, 7, 8 ends up down here, and then that row. That row becomes this row. This row is the last row. So that's the function to transpose a matrix using the SIMD functions. Now, if you remember, let me see. I think I might, okay, here, this is the matrix transpose program that I copied over. So yeah, this is the documentation that I've been working with today. It looks like the next thing that we're up to working with is elimination of conditional branches in your programming. If you're doing SIMD programming, then you want to get rid of your conditional branches, and especially if you're working on a CPU like the cell CPU, because the cell CPU doesn't have very good branch prediction logic, like your modern x86s will have. They have very good branch prediction, but the PS3's cell is like rudimentary, more or less, when it comes to that. So you don't want to be taking you don't want to have a whole lot of conditional branches in your code. So there's a SIMD way of doing a branch equivalent processing. So when different operations have to be performed according to set conditions. Scalar processors, that's non-SIMD. First evaluate the given condition as shown. Figure 212, that's the first one. Yeah, there's a condition. You either go to true or you go to false, right? See, the use of branch instructions affects the efficiency of SIMD operations because it requires decomposing each vector into elements and processing them sequentially. SIMD processors therefore employ another method to obtain the same result as conditional branching. Let's see. SIMD processors provide the equivalent operation while maintaining their efficiency. Okay. Okay, this is pretty complicated right here. Looks like you do both you solve both paths and then pick afterwards which one is the right one. Well, the best way to learn is to do, right? So let's take a look here and see if it starts making any sense. I guess I'll keep with my convention of naming these things after SIMD function. We'll call it vec CMPGT. Oh, well, no, it's well, actually, I'm most recently I was a student. I went back to school to try to finish my bachelor's, but I ended up just getting another associate's instead. So now I have two associates. My first associates I got was electronics engineering. That's when I got that after high school, and then some years after that I went back to school. Um, Around about 2013 or so, and since then I've kind of been in and out. But yeah, I was originally going to try and finish my bachelor's, and I was majoring in mathematics. Um, but it looks like that wasn't meant to be. So I switched schools and I switched majors to computer science. So now I just got my associates in computer science. I'm not going to keep going though because I know it's not a great time to be looking for a job, especially in my country at the moment. But I'd rather I'm sick of school for now. I want to go back and start paying some taxes. I'm doing Vec. It's a challenge though. I feel like I've gotten like I've always been I've always been kind of autistic, but I feel like I've gotten like more autistic these past couple of years. I blame school. Uh been heavy on my nerves. GT.C. Um There, see, there's altavec.h. That's where you'll find all the definitions for all the funny looking uh data types and functions that we're working with. Those are all going to be defined in here. Altavec.h. Oh, and before school, you know what I used to do? I was a mechanic. um yeah, I was an auto mechanic, but um I might as well have been I might as well have been flipping burgers really for all the money I made. You can't make a living as a mechanic really these days. At least I couldn't. Yeah, this directive here, attribute aligned 16, that tells the compiler that you want your we want this array to be aligned on a 16-byte boundary in memory. That's something that you're going to see a lot of when you're doing SIMD operations. Your memory has to be lined up correct. Oh, hey Mustafa, good to see you. Quality of instructors at my college. Oh, well, at the one that I'm currently at, or the one that I don't go to anymore, because I got pretty strong opinions on both at this point. Well, not both. I mean, the place that I just graduated from, or the place that I'm getting my associates from. Uh, I actually have graduation this month. My quote unquote graduation. It's gonna be this month, but uh, yeah. Well, I love the Ocean County. That's where I'm graduating from. It's a county college here in New Jersey. So I have nothing to complain about. I did my well, chemistry was a pain in the ass, rough. I ended up dropping out of Chem 2 because I guess this could happen at any school. It's not like the school's fault, but what happened was when you're taking a class that has a lab attached to it, right? And like you're ideally you're supposed to like be doing the same subject in like both classes, like if you have a separate teacher for your lab and for your like regular class, then sometimes what happens is like one of your classes will get ahead of the other one. And unfortunately for me, it was the lab class. So yeah, all of a sudden we're like two chapters ahead of ourselves, like ahead of where we are in like the lecture class, trying to do these labs that we haven't had lectures on yet. So I don't know how we were expected to know how to do you know, to understand the material um, in the labs, since we're way ahead of where we were in the lecture class. That's bad communication. I don't know. Something fell apart there. You can't you That was an impossible situation. Anyway, but that's like a rare thing to happen. I took my data structures and algorithms course over there in Java, and that was great. I took a C++ course over there. That was great. I even had to take some of my freaking like fill up some of my requirements. I took piano. I took karate. Because I had to take a fucking physical ed for some reason. Um, I took some Spanish. I took some German. Yeah, I took a little bit of everything at that school over the years, on and off. But yeah, the one that I tried to go to finish my finish my bachelor's and get a math degree. I'm actually only three classes away from my math degree, but it's just so expensive to even try to buy courses at, because what happens is, like, once you have so many credits, like they're all tied up at a certain school, and you're kind of locked into that school if you want to finish. Otherwise, you gotta retake all kind of shit, because it's at the end of the day, it's actually a big scam. Um, but I'm sure you guys know that. Um, yeah. Uh, my time at the other school, which I won't name because I'm too much of a gentleman, uh, ended up not being a pretty good experience. It started off really good. I was, I actually, like the head of the math department, selected me for a what they call a research fellowship. Not everyone gets those, especially as an underclassman. But because she was really impressed with my work in my C courses, because I took C over there. Like, I took programming with my the head of my math department, and yeah, she thought, she thought I was, I could use a what's called a research fellowship, and I actually got it. It was NASA, uh, a NASA program, and they actually gave me some checks towards my uh to go to my tuition and everything. It's grant money, um, and that was pretty cool. That was nice. They had like an academic excellence night where they had me they gave me a certificate, like, and they let me talk about like a program that I was developing for my C course, which was a blackjack like a blackjack trainer to try to help you learn how to uh, uh, how to play a basic strategy in blackjack and kind of um, lose the least amount of money over time. Basically, it's what all the professionals do when they play blackjack. Um, so yeah, I did that. Yeah, so yeah, things were going good over there for a while, but eventually the math became impossible. Like the workload became impossible. Uh, it got to the point where I was only doing work for my math course. Like I was only doing work for that one professor. If I was taking four courses at a time, um, three of them I would do almost nothing for because I would never be finished doing the work for that one professor. Um, which I don't think is actually a good. I don't think that's a good way to run your school. Um, yeah, big waste of money actually. Then one time we were supposed to be, well, we were taking it was like during finals week, um, and rather than being available, this head of the math department was vacationing in India. She conducted one course one that I was in that I took where every student failed. Um, Somehow none of us were able to decipher what she wanted. Yeah, yeah, that's a huge red flag. Yeah, that's not a student problem where everyone fails. Um, and she had the audacity to sometimes come into class like crying, uh like uh I don't know, like we weren't trying hard enough. I don't know, like we were uh the the ones that were fucked up. uh no, sometimes the problem's not sometimes the problem's not everybody else. Sometimes the problem's, you're you. One of her favorite things that she used to like to say was, "I don't teach to the test. I don't teach to the test." And I guess that was like just something that she felt proud about because like teaching to the test would be something that would be beneath her. Like what, teaching the material that's going to be on the test? That's beneath you? Really? I don't teach to the test. I don't teach to the test. I just teach theory. No, one day I swear to God, I almost stood up and said, well, maybe you should fucking start. And I wasn't the only one that was thinking it. Yeah, that was an expensive school. I used to type out my abstract algebra homework. It's one of the reasons I had to use Windows for as long as I did because Windows Microsoft Office happens to have the best in my opinion. I mean, short of having to learn like LaTeX or whatever they call it, LaTeX, the language for doing for typing math reports. Um, you know, besides learning that, I'd have to say that the best thing for typing up math equations is definitely Microsoft Word. I haven't found a I haven't found a good alternative in Linux ever since I gave up Windows. Like I said, there is LaTeX, but I don't really feel like learning kind of like a new language at the moment. Do I think people should learn C++? plus plus? At this point, I don't know. It seems to me like in the programming world, um, things are going more towards like the Rust direction. That seems like it's only getting more popular. Like memory safe, quote unquote memory safe languages, like Rust. I think those are gonna be like the more future proof thing that you could learn. You know? Oh yeah, I would probably agree. I think C is probably the way that I learn. I don't know. Maybe I learn backwards from the way that other people do. Like to me, C is like more simpler to me. You know, because the syntax is really simple. It's you know, it's I wonder why. Did I forget a did I forget a parenthesis or something? Maybe not. Yeah. See, well, when my first language, that the first one that I actually did anything in, back in the day, like when I first got a computer was assembler. I started learning x86 assembler on a 486 machine. Um, and yeah, I think the biggest project I ever made in assembler on x86 was back when I was like 12. I made like what's called a war dialer. It's it works through like a modem, and it picks up the phone and it just starts dialing all the numbers that you give it like within a certain range, and it looks for other computers, and if it finds another computer, then and it logs that phone number so that you can call it back later. Because you know I was a little wannabe hacker. I was an antisocial little prick. Yeah, nmap for yeah. Yeah, it's like checking all the ports, right? Let me see, what's the year? It's 2020, I'm 44. Yeah, I told you guys I'm on the bad side of 40. Now, I keep getting the impression that I've done something wrong here. Uh-oh. Maybe not. Decade? Yeah, I was born in the 80s. I was born 81. I'm actually the oldest millennial, believe it or not. If you like technically you're a millennial if you were born after 1981. Yeah, I was born January, so that makes me the oldest. Let's see. Um, yeah, so these aligned bytes, what oh, this is a comparison. We're we're seeing which one's greater, right? Um, this is a greater than or less than check. Uh, is what we're going to be doing. which means, okay, we're gonna cast all these. I think we're basically kind of like manually creating unions right here. This is like an IBM convention, I think, that we're seeing at the moment. Uh, Defining or declaring these arrays and then casting them to vector types. That's a very IBM like way of coding. Oh yeah, especially the project I chose had me manipulating like hardware because I had to communicate with the modem. So I had to learn how to use on x86 you have two commands, in and out, and that's how you write memory to like a certain memory port, or at least that's how you used to do it. I don't know if it's still the same. Modern x86s are modern x86s are very complicated devices, way more so than the old 486. What's all that gibberish you're talking? Neuralink brains. I just realized that I just realized my new computer, the Victus that I got recently. Um, I wonder if that has a NPU in it, one of them so-called neural processing units for doing whatever Microsoft wants to do with AI. I wonder if it's doing anything in there without my knowledge. I think it's just those Microsoft computers that have NPUs right now. Those whatever those things are called, the tablet things, the Surface. Don't they have AI like built in? Oh shit, IBM patented DNA computing. Huh. I wonder if that's similar to like protein folding, because I know the PS3 was used for that famously. Let's see, vector unsigned integers, VPAT. Um, VPAT is going to be some kind of a pattern. That's what that means. Most of the world's data fits in a few grams. Well, I know if you took all the water out of a person's body, all that would be left is a few grams of dust, right? This right here, this part in blue, this is our branchless logic right there. Yeah, DNA is fragile. That's why everybody seems to get cancer these days. Holy shit. Really? 215 petabytes? That's a shit ton of bytes. Apple Intelligence. Is that an oxymoron? Sorry, I'm being smart. Everything Apple's cool as shit. Hey, Cosmopock is here. What's up, Cosmopock? Where's the cat? The cat's in the cloud. I don't want to tell you where I got the thumbnail from for this stream. I got it from the chatbot. Yeah, that's an AI picture. I told it coding with kitty, and that's what it gave me. Hmm. You know why? Because it didn't draw it with like four front paws or like, like two like two tails. AI likes to fuck up and draw like, extra limbs sometimes. Oh my, I still got my anime girls. They're still around. Do I have AI installed locally? Well, I have a chat client. I have a terminal client installed on my PS3. You want to see it? I run SGPT. Give it a second. Yeah, branchless programming is quite weird. You actually you execute both branches and then you select afterwards the proper like the proper answers, the proper selections. See what it told me. Cell broadband engine, which is used in devices like the PS3. Some high performance computing applications. Yeah. Well, it knows about libSPE too. That's how you communicate with the SPEs. Provides a simple interface for managing SPE threads and communication. Yeah. IBM SDK for multi-core acceleration. Yeah, I got that. I got that installed. What's the trick? Have you heard of pip? You can install it with pip. If you have Python 3 installed, run this. If you get a response that looks like this, that means you have pip 3, right? So yeah, if you have pip 3 installed on your computer, you type in pip 3 install user sgpt, and it'll install. Of course, mine's already installed, so nothing to do. Then if you want to run it, you just run sgpt, you can say help. Oh shit. Run it as a flag like that. There, that's all the stuff that you can do. I don't use most of this crap. All I use is if you run it with this option here, the chat option, then you can specify the name of a chat that will persist, you know, and you can have an actual conversation. It can do more than just code too. Check this out. Um, you want to get inspiration for writing a song? You can get it from ChatGPT. Look at that. If you guys don't know anything about guitar, that's guitar tablature. You can play that on guitar. And it all works on my PS3. All right, I hope I didn't fuck this thing up. I keep thinking like I forgot something. Well, let me print out this for loop and we'll see if it runs. Did I use Suno for music? I'm not sure what that is. Bitnet? I've never heard of that. I've heard of botnet. Oh, AI to create music. No, I never tried that. Um, like something that would kick out a real song? No. I always assumed that that would cost money. But ChatGPT can give you some, simple tablature to get you started. Suno AI is great. I could probably use something like that to, make my background beats. Ask it for lyrics and paste them to Suno. Let me check out Suno. Let me see if I can find the website. Oh, there it is. AI music. Oh yeah, Mustafa. Yeah. Yeah, if you could follow the logic here in the branchless example they give. So they give you these two they give you these two arrays full of integers, right? And you're going to compare them each number by each number, and we're going to compare them to see which one's greater than, right? And here's all the logic right here. We're going to set the elements of v pattern. That's this vector here is equal to the result of this SIMD function here, vec cmpgt. In fact, let me look that up. Vec cmpgt. That's an altavec function. Let's see what it does. Huh. Oh, it's not on this web page. This web page is some other language. Oh yeah, compare greater than, right? Or compare if greater than. So I'll bet you it'll compare if this first argument is greater than the second argument. Oh, there's no man page for it. Yeah, VC true is a unsigned integer, or is a signed integer, and VC false is a signed integer. and then VC will store the result, and VecCell is vector select, I think. And we're gonna send it the false value, the true value, and or the false argument, the true argument, and the pattern vector that we populated up here. And then we're supposed to just print out the contents of array C, which should equal the contents of vector C, right? Let's see if it compiles. I'm going to pull in one of my make files. Make a few changes. Oh, I knew I must have fucked something up. Let's see. Line 21. Let's take a look. Vector A, vector B. See here. Attribute align 16. Regular integer, fine, okay. Vector signed int. I wonder if these when you don't specify an integer, whether it's signed or unsigned, doesn't that generally default to signed? Maybe I should be explicit. I don't think I misspelled anything, right? Differing element types or numbers of subparts. Says are incompatible types when assigning to type vector unsigned int. from type vector bool int. Where the hell is it finding a vector bool int? Yeah, that's the same thing that I wrote. 19. I wonder what this does. Well, that would be the smart thing to try, wouldn't it? Let's try that. Casting to an integer instead of a signed int. Oh, you know what? I wonder, yeah. Oh. I wonder if I should change vector unsigned int vpat. I wonder if that should be a bool. Oh, Mustafa, good eyes. I wonder if you're right. Oops. Hey, who's the smart guy now? Who's the smart guy in the chat? Mustafa, you got good eyes. Yeah, but spitballing, that's how you fix things. That's how things get figured out. Wow, we found a so we found a glitch in the tutorial. How about that? Vector unsigned this vector is supposed to be a bool because this function returns a bool. Aha. Good job, chat. We've cracked it. Let's see what it outputs. And there it is. That's the contents of our our array C. Yeah, yeah, definitely. I feel like I got something accomplished tonight. Um, I think I'm gonna be putting this on GitHub, especially since the fact that I'm making alterations to it and you know, I'm making updates to it. I'm gonna turn this into a GitHub project and kind of turn it into I'm gonna add my own comments and everything, trying to turn it into like a decent tutorial, uh, so that maybe other people could get some use out of it as well. Yeah, error messages. I'm still getting used to all these all the C error messages. Um, Getting better at it though. It's because of all the software I've been building. Actually, that reminds me. I have something that I've been meaning to build today on the PS3. I want to see if let me see if I can find my M player release. Oh, here we go. Oh yeah, the problem it might yeah, error messages get better over time, right? Um, yeah, the compiler that I'm currently using is oops. Yeah. This is the compiler that I'm using. Um, oh shit, that's very strange. This shouldn't be the compiler that I'm using. Did I set my CC flag? Oh, oh Jesus. I forgot. When I built my new compiler, I gave it a suffix to its name so that I could call them both from the same, so that I to call the new one, I have to give its version number. So yeah, CC is set to my new compiler. There it is. This is the GCC that I'm using right now. 4.8.5. I like this one because it has support for C++11, which the 4.4.4 doesn't have. No, I highly doubt it, unless the tutorial is referencing a earlier version of the SDK, because there were breakages between the different versions of the software development kit. Um, yeah, they're incompatible with each other, and I'm running the latest and greatest, 3.0, like a hybrid of 3.0 and 3.1. How old is this release? Well, I can tell you this much: the RPMs, the software development kit that I have installed on my computer now, or on my PS3 right now, was designed for to be compatible with Fedora 9. It was designed to be installed on Fedora 9. I'm just very lucky that it still works on Fedora 12, because Fedora 12 is such a big step up over Fedora 9. It's such a nicer OS. Yeah, I think GCC's up to version probably 15. Or it might not be released yet. It might still be a release candidate, but yeah, I think GCC's up to 15 at this point. You guys want to see something cool? Um, I go to under here. This is Jeff's kernel web directory. Um, check this out. There's a project here called Mars. Here, I'll show you the presentation. Um, I'm gonna take a little break. When I get back, we're gonna I think I'd like to compile this project and show you. This is a runtime system for the Cell Broadband Engine. Obviously, it's it's basically like an API for working with the SPUs, and it's a little bit more abstraction. It's a little bit higher abstraction than working like directly with libSPE2 in order to manipulate your SPU programs. And yeah, this was designed as like a kind of like a wrapper around your SPU cores to do a lot of the work for you, like the lower level work. And we're gonna install it. There's some pretty cool little projects in here that that can make use of these libraries. But anyway, yeah, just give me a second. I'll be back in a second. Mhm. Okay, sorry about that. Sorry about that, everybody. Had to take a little break. Here, let me show you something. Yeah, check this out. This project here, the Mars project for the PS3 cell, um, kind of it has its own like API and its own like interface and everything. It's supposed to make cell programming like easier. So this is a pretty cool project, right? Synchronization. Now yeah, this project actually gives you an example of OpenSSL running on the cell. I wonder if I can make that work. We'll see. I messed up. I overwrote my SSL installation with a newer one, so it might not. I don't know. That might make it not work, but we'll give it a try. It also comes with a zlib implementation, and I'm pretty sure that one works, so we can benchmark it. All right, here's the Mars documentation. This is the official documentation for the API. It's pretty complete. And here's the yeah, here's the tarballs. First, we gotta install this thing, the Mars libraries. Okay, here's the configure instructions. I guess let me try building the 64-bit first. That may fail. I think if my memory serves me, I've done this before. This one may fail, but pretty sure the 32-bit is working. to set CC equals, let's see, I'm going to set it equal to, I'll try out my new compiler, see if it works. Uh-oh, I wonder if I should have set CXX also equal to G++. Maybe I'll do that. Why not? I'll try that again. All right. Yeah, hopefully that'll do it. Like I said, I'm pretty sure the 64-bit build sometimes fails. I can't remember why. Hey, well, what do you know? Check it out. The 64-bit library is built for Mars. I think that must have been the secret. You have to set your CC compiler to 64-bit mode. I'll have to remember that. Mustafa, are you asking on my streaming computer, like on my laptop, how many cores? This is a 12-core computer. Yeah, this is the machine that I'm streaming from right here. It's got 8 gigs of RAM, and it's a Ryzen 5 12-core CPU. Oh, I'm SSH'd into my PS3 in both of these terminals. I'm logged into the PS3. So yeah, I'm doing all this work over SSH. PS3, physically it has 9. It has 9 cores. It's got 8 SPUs, and then the main core, the PPU. But from Linux, you only have access to 6 SPUs, so a total of 7 basically. 7 cores, 1 PPU, and 6 SPUs in Linux. Okay, so our 64-bit build of Mars went perfectly. Let's build the 32-bit. Uh-huh. Oh, very cool. Yeah, Gen 2 will run nice on there. Intel Atom, wow. Okay, 32-bit is done configuring. Let's go ahead and build our 32-bit Mars libraries. Oh, you can't do Gen 2 unless you have patience, right? It'll help you work on your patience. Okay, we've got our 32-bit Mars. Oh, you're gonna use DistCC. I love DistCC. That's the best. I got it running on my Fedora my desktop rig, my home built rig. Yeah, I just keep it running on there all the time because in case I want to boot my PS3 into Gen 2 and install anything, so it's always running. Wow, yes, Intel Atom is single core, right? Wow. That's rough. How did we ever manage back in the day with only single core chips? That seems so primitive now. Yeah, that's true, Mustafa. Uh, over time, all software just seems to just do nothing but get more bloated and more bloated. It never gets like less bloated over time, you know? That's not a thing that happens. All right, check this out. We're gonna build a new zlib. Zlib is a compression library in Linux. It's a very popular library. A lot of projects use it. Now this project right here is going to be a zlib that's ported to use the Cell CPU's accelerators, um, which is fucking awesome. Any pointers for distcc for the uninitiated? Well, do you use what do you use? Do you use what type of init system do you use? Do you use systemd or do you use OpenRC? Because I have mine configured to automatically run when the computer starts up, and I made a systemd unit file to do that. I'll show it to you. This is my Asus computer. This is the computer that I've got distcc running on. Oh, well, you'll still be able to use this information, but you'll just have to use a different init system. Yeah, there's my distcc service. It's running. It's active. It's always running. Okay, here's how I've got my system set up. Let me show you. If you haven't built a cross compiler yet, then you're going to want to build a cross compiler, and you can do that with the crosstool ng project. You go to GitHub and you type in crosstool ng. That'll bring you up to this project here, and then you're going to want to clone this and build this project from the source code. And after you do that, here, in case you don't have the URL, that's where you get crosstool ng. So you're going to use crosstool ng, and then you're going to use that to build your cross-compiling toolchain. I've got mine installed under /opt/xtools. I've got these two. I built these two tool chains. The one that I use mostly for with the PS3 is this one here, because Gen 2 for PowerPC is not multilib. And I think they're under bin. Yeah, this is my cross-compiling toolchain right here. I built this with the crosstool ng project, and so yeah, you install your cross-compiling toolchain to whatever directory you're going to install it to. For me, it's this one here. And that's a very important directory. You're going to use this directory when you invoke your distcc daemon, and you're going to do that by this is how I invoke the distcc daemon, the server. You're gonna run. You want to set your path equal to the directory where your cross-compiling toolchain lives. That's what this is, and I've got that as the only thing in my path. And then you're gonna run exec distccd. You're gonna run it with no detach daemon. You're gonna give it the amount of maximum jobs that it can do. For me, it's 3. The IP address that you're gonna allow connections from. And I have to use enable TCP and secure for mine to work. And then set your log level. I set it to info. Yeah, that's the command line string that I got from the Gen 2 documentation. If you want, you can actually run distcc. You can run the daemon from a command line and just have it run in the terminal, and then you can have it like dump out its output straight to the terminal, so you can watch it work. I used to do that like all the time until I kind of got used to I got bored of watching it work. So now I just dump all the log messages to journal CTL. But yeah, that's what I use to just the important thing is make sure that you set the path. You set the path to the tool chain that you want to use. Like this when you run the daemon. Otherwise, it'll just search your regular path, and it won't find your cross compiler. So this is the important part right here. Make sure the path is set. Yeah, let me know if you run into any problems. I'll I've read the documentation for distcc. I've gone through it a lot because I make heavy use of distcc here on my network. um, all right, so yeah, I'm gonna try out this. This is a port of zlib for the cell broadband engine with acceleration. I want to test it out and see if it builds. And if we can get it to build, then we can benchmark it. We can take a look at the difference of running our program just on the PowerPC core and then running it on the SPU cores as well. I think I'm going to have to download a version of zlib as well because it doesn't come with it. I think it's 1.2.3. Okay, what do we got here? This is zlib library, partially ported on Mars, which is intended to be a reference of porting existing libraries on Mars. Yeah, so like if I want to learn how to port something to run on the cell with acceleration, this is the kind of shit that I really need to be studying. Okay, so it looks like only the compression routine is ported. Decompression just runs on the PPE, so only compression is accelerated. It comes with a program called mgzip. That's gonna be how we're gonna test it out. Okay, type make in this directory. The original zlib and mgzip source codes will be downloaded. Oh no, they won't be because whatever website it's gonna try to download from doesn't exist anymore. It's okay, I downloaded it already. Mars ported libz.a. That's a static library. Oh, hey, Briney. Yeah, it's pretty crazy, right? Yeah. If you're just joining us, yeah, I'm logged into the PS3 here in this terminal, and we're building some projects in Linux that were ported to use the cell CPUs accelerators. The project that we're trying to build right now is called zlib. That's a compression library. It's a very popular compression library in Linux. It's used by many programs. Apparently it'll build if we just run this right here. Make post flag equals M32. Oh, you're awesome. You got Linux installed as well. And doing OS. I don't think I've heard of that one before. I'm I'm actually on Gen 2 at the moment. This is my Gen 2 laptop. Yeah, I enjoy Gen 2. It takes some patience, you know, because you got to wait for things to install. But and there's a kind of a there's a learning curve. The use flag system is kind of complicated, but if you can wrap your mind around it, it's a pretty fun distro. But here's Anduin. Standard long time support. What type of package manager does Anduin use? Does it use RPM packages or does it use Debian packages? Oh, it still tried to download the program. I gotta see if I can find this tarball right here. Oh, maybe I have heard of Anduin. Yeah, the distro that was made by the Microsoft guy. I think I saw something on YouTube about it. Huh. Okay, I've got to download this file right here, mgzip. And try that build again. Mhm. Oh, it's a Debian derivative. Okay. Yeah, I actually I used to use Debian. Like before I switched over to Fedora. Yeah, Debian was my distro. Um, the reason why I switched over to Fedora on most of my machines is for the past few years is because of the PlayStation 3. It's because that was the best distro that I found for running on the PS3. So I decided to make all my machines Fedora. Oh, this is weird. My gzip isn't working. Hmm. Oh, use flags? Well, use flags. You know what I find is the best way to use use flags is after you first install your Gen 2, you're gonna have you're not gonna have a use flags variable in your make.conf file. You have to make one yourself. Start off with either X, or just Wayland, something really simple that you know you're definitely gonna want to have enabled. Um, whether you choose X or Wayland, either one, but just have one of those enabled, and then kind of let your use flags kind of grow organically as your system grows. Um, you're gonna want to put a lot of use flags like in their own separate files. Um, yeah. um, because that's just um my biggest advice would be very careful about the use flags that you add to your like your global set of use flags, the ones that are in your make.conf file, because you could make just one change, and then the next time you do a system update, Portage is going to try and rebuild your entire system. And you won't, it'll be because you just made one little change to your make.conf use flags. So yeah, don't change those too often. Just kind of let them kind of, when you come across one that you're gonna want to be that you're sure and positive that you're gonna want to have either enabled or disabled for the entire system, then add it to your like global use flags. Um, but when you're rather than using your global make.conf use flags variable, you're mostly going to want to create little files with like one line of text in them, just to turn off or turn on use flags on like specific packages, and they go in a certain subdirectory. I think it's sorry, my kitty cat's talking to me. I think it's /etc/portage slash packages.use. That's where you put your little one-liner files with your use flags in them. That's the better place to set them for the most part than doing it globally. That's my take on use flags. And apparently this gzip is broken. It doesn't seem to be working for me. Let me try downloading from somewhere else. Yeah, that's yeah. The Gen 2 can be really annoying that way. Like also portage will sometimes portage will only give you like one hint at a time. Like when portage fails to emerge something that you're trying to install, and you've got conflicted use flags. You may have like many conflicts, but portage will only show you like one error at a time. So you've got to run emerge update, have it fail, fix the one thing that it tells you to fix, run emerge update again, have it fail, fix the one thing that it tells you to fix, run it again, have it fail, fix the one thing it tells you to have it fixed. Yeah, it can't give you an entire list of conflicts. It can only give out one at a time, and you have to just stop every time you run portage if it fails, and then make edit some text file, and then or create some text file, in some certain directory, and then run it again. And if it doesn't work, and then you have to fix another error. Yeah, you'll run into that sometimes. Portage can be a bitch. Okay, that time it worked. Huh. Alright, well supposedly if to build our 32-bit libraries, all I have to do is run this command right here. Let's go to try. Actually, let's try to build the 64-bit first. See if it works. Well, it sounds like uh, uh, honestly, like most distros are probably pretty well optimized as far as they can be. Like, just the way that they're delivered. Um, you can probably the best optimization you can get in Linux, I think, is from building your own kernels. Actually, because you can really strip out a lot of bloat out of a modern Linux kernel. You can make them pretty lean and mean. All right, let's hope this works. Oh, I have to add this environment variable. Shit. All right, here we go again. Trying to configure our zlib 64-bit library for that is accelerated on the cell CPU. Oh yeah, a lot of Arch people like to build their own kernels too. Yeah, well, I always build my own kernel on the PS3. You kind of have to. Wow, looks like our 64-bit zlib is built. Wow. So, is there an install directive? Nope, no install. Oh, thanks. I can't take any credit for it. Believe it or not, that was the chatbot. The chatbot made that for me. I prompted it. I said, coding with Kitty. That's what it spit out. Not too bad, right? Okay, looks like our mgzip, our 64-bit mgzip executable is this guy right here. But I'm not gonna install that one. I'm gonna follow my system's convention. I'm gonna install the 32-bit one, but I am gonna copy over the libraries, possibly. Let's see. Okay, now I gotta run make libz so123. Let's see if this works. Holy shit, it worked. Yeah, the desktop that I'm using right now on this computer, this is XFCE. On my streaming laptop. Ah, guten Abend, mein Freund. Alles klar. Ausgezeichnet. Very good. Wie geht's dir? Always nice to have a German friend in the chat. Oh, no, this is OBS running on my laptop. I'm connected to the PS3 through my terminal here. That's where I'm doing all my work. I just built a 64-bit zlib compression library. It's a very popular library in Linux that is built to take advantage of the cell CPU. I'm going to copy it onto my system and overwrite the original libc that came with Fedora. Okay, now I'm going to create some symlinks to copy these right here. I need a libc so and a libc so.1. Oh, and there may be a static library as well here in this directory. Yep, there it is. I'm going to copy that over as well. Okay, there's all of our 64-bit libc libraries optimized for the cell. Now I'm going to rebuild for the 32-bit, and then I'm also going to install the mgzip utility, and then we're going to benchmark it. We're going to do a compression test of some large file, and we'll run it with both without the SPU accelerators, and we'll run it with the SPU accelerators, and we'll see how much faster it goes. Oh no, appointment at 8:30. That's much too early. Too early for me. All right, so I've copied all the libraries out of this directory that I need to copy. And like I said, I'm gonna follow my system's prerogative, and I'm gonna install the 32-bit mgzip instead of 64 because this system favors 32 over 64. So all right, here we go. I gotta delete this directory. And we'll open it up again. Okay, here we go, 32-bit build. Oh yeah, very very important in Germany. If you're ever in Germany, don't be late for things. That's very rude. German people don't like that. I'm kind of bad at that actually. I'm late for everything. Generally. Okay, so beautiful. We've built our binary mgzip, and I'll leave that there for a minute, and then we'll copy it over to our binary executable directory. Let's see. Oh, we have to build our libraries. Gonna run make on this target. Oh, the 32-bit failed. Oh, that sucks. Always late. Immer spät. I can translate some things. German friends, deutsche Freunde. Wow, I wouldn't even know where to start to try to figure out what's wrong with this thing. Oh well, we don't get the we won't get our 32-bit libraries. I wonder if the mgzip binary will work. It'll work if it's statically linked. It uses shared libraries. I wonder which ones. It uses libnuma, user local libgcc, librt, libpthread. Okay, it uses libmars. That's installed. That's no problem. And libspe too. Okay, so this will work. All right, whatever. I'll have the 32-bit mgzip installed with the 64-bit libraries. It's okay. It makes my system quirky. Okay, we've got our mgzip installed. Now we can benchmark how long it takes to create an archive. Let me copy in some video files that I can use for to test on. Oh, hey, Mustafa. Yeah, I think I fucked up the 32-bit compile. If I want to install those libraries, I can try again. Let's see. Let's pick a video. Let's pick one that's pretty big. Here we go. 518 megabytes. Chat, everybody, um, what everybody should do is make a bet. Make a bet and put like a time and like how many minutes do you think it'll take to compress 518 megabytes. We're gonna benchmark the difference between running gzip on the single PPU core, and then we're gonna run it on the full cell broadband engine with the SPU cores. We're gonna be compressing a video. I'm gonna set the compression to like very minimal because there's no point trying to compress an MP4. It's already compressed. But yeah, you should all try to guess how long it's gonna take. I don't know. I'm gonna say like 5 minutes for the PPU run, maybe 2 minutes for the I don't know, maybe 5 minutes for the accelerated run, maybe like 8 minutes for the PPU run. It's hard to say. Let's find out. All right. So we're gonna do a PPU run first, which means I'm gonna run regular gzip. Okay. The way you run gzip is kind of strange. You're gonna set it to output to standard out, and then you're gonna redirect that output to a file. I was gonna say 5 and 2, but 2 may be way too short. Maybe way too optimistic. We'll see how she does. So yeah, we're gonna run gzip with the C flag. We're gonna run C suffix test verbose. Oh, we're gonna set the compression speed or the compression level from fast to best. We're gonna set it to fast because, like I said, there's no point trying to compress an MP4 file. Okay, so those are the flags that we're gonna send it. The file is gonna be what's it called? G4 PS3 launch event megathon. And then we're going to redirect the output from standard out into a file. And the file is going to be called .gz. And I'll run it with the time command, so we can see how long it takes. Okay, here we go. This is our PPU run of compressing a 500 and something megabyte MP4 file, and I'm gonna see how long it takes with the time command. Here we go. In the meantime, I'm gonna smoke a little bit. Oh, should I have put the double ampersand? I didn't think you used that with time. Oh well, we'll find out. Oh, here. Want to see how hard my PS3 is working? We can watch. There we go. There's my gzip process. It's single threaded. Oh, Einfuck. Yeah, did you join my Discord? Yeah, definitely don't forget to do that. We're a pretty fun little group of friends here. All right, so that wasn't so bad. Looks like 2 minutes and point zero something here. All right, so pretty good, right? I'm gonna go ahead and delete this file, and then we're gonna recreate it. Now this time we're gonna run it with the accelerators, the SPUs. MGZip is gonna have a little bit different syntax, so but we're gonna be able to do the same thing though. Oh wait, the syntax is basically the same. We're going to use the C flag to write the data to standard out. I don't know what chunk size is, so I'm just going to leave that as default. Prints the license. Let's see. Oh, here's what I was looking for. Lowercase t is where you set how many worker threads. I'm going to set it to 6, the same number as how many SPU cores that I have. No, HTOP doesn't show the SPUs. It only shows the PPU, the dual-threaded, the two-threaded PPU. But I do have a program that I built called HTOP. I mean, not HTOP, SPU top. And this will show my SPU threads. They're not doing anything at the moment, obviously. But when I run this command, you'll be able to see them working. So I'm going to run time. MGZip. I'm going to set C. I'm going to set T to 6. And I'm going to set the 1 right here. That's the file name that we're going to compress right there. And we're going to redirect to a file called that. All right, so this should take way less than 2 minutes, as long as I entered everything correctly. So here we go. Watch the top. See if my SPU cores start waking up. Here we go. Hey, we got gzip on the SPUs. Check it out. Gzip is compressing. I'm using a compression library on my fucking cell CPU accelerators. I think that's fucking amazing. I think that's fucking miraculous. I resurrected an ancient abandoned cell project, and I got it to build. Ooh, check it out. Look. See? Krasniez knows what I'm talking about. He gets it. Well, excuse me. Well, there you have it. The difference between gzipping something on the PPU core compared to gzipping something that's optimized for the cell. It's a difference between 2 minutes or 2.01 minutes and 0 minutes and 45 seconds. Crazy NES. Okay, I get it. That makes sense. I can see that now. Crazy NES. You know, I have an emulator installed on this PS3 for NES. It's called Fake NES. I could show you how I could show you some of the games that I can play on there. I got Mike Tyson's Punch Out. So yeah, there you go. That's our we've just run our gzip using gzip compression on our cell CPU. It was a project that's been abandoned for ever since zlib version 1.2.3. But that's the magic of open source. I found it, I downloaded the source code, I built it, and I made it work. And I could start maintaining it now if I wanted to, if I had the wherewithal. If I was a little bit better at my C programming. I'm getting there. There is another project available here that utilizes the Mars libraries. I'll show it to you. Yeah, it's a OpenSSL. That's a cryptography library. It's an OpenSSL cell CPU engine. And I wonder if I can get this to build. Check it out. Look at all the SPU source code. All these SPE C files that are named after algorithms. There's a benchmarking test thing in here? Yeah, that'll be cool to run. I hope I can build it. Wow, it comes with a spec file. You can use spec files to build RPM packages. Let's check the README. Yeah, it's implemented as an engine, which is like a shared library, I guess. Which functions are beneficial? Currently, the functions below are accelerated or offloaded. Message digests, MD5, SHA, okay. Ciphers, I don't know, I don't really know ciphers that well. Compiling. Um, okay, yeah. This might be an issue because I'm going to be working with a very old OpenSSL file here. And I've already replaced my my previous installation of OpenSSL on this distro. I upgraded it in place from source code. I have clobbered my original OpenSSL installation, so we'll see if this works or not. Okay, I gotta try and download this old ass library here, OpenSSL library. Here we go. Okay, run make command in this directory, OpenSSL dir. Oh, okay. God damn. A lot of flags I gotta use. A lot of I gotta set a lot of um a lot of environment variables. Cross, SPU cross. You like to build a binary for a different architecture from your compiler's default. Okay, yeah. Yeah, I'll try the 64-bit first. Okay, I need to set I set arch flags to M64. Okay, arch flags to M64. And we're going to set the runtime system. We're going to try libspe2 first, because you can pick libspe2 or Mars. Try libspe2. I'm system. Okay, let's see if that builds. Let's see if it does what it's supposed to do. Oh shit. Wonder. Wonder if a 32-bit build will work. Try 32. I wonder. Let me see what kind of header files this ecell.c is pulling in. Well, yeah, this could be the problem here. This header file right here. This is not the same header file that on my system that came bundled with Fedora 12. I actually I installed my own OpenSSL installation on top of the original OpenSSL from this operating system, and I clobbered it. You know, I just installed right over top of it. So the original OpenSSL that this project was probably built against is not there, and it's looking for that. It's importing this header file, and it's not finding the resources that it's looking for. So I think that's my fault. Yeah, I installed over my original OpenSSL. Whoopsie daisy. I'm pretty sure that's why this is not working. One thing that I did kind of want to get started was I need I need to build a video player. I downloaded an older release of MPlayer, and I wanted to get that compiling. Oh, very cool. All right, yeah. I'm gonna go ahead and start this MPlayer build because this is a really good video player for the PS3, and then maybe we'll give it a little benchmark on the on the actual PS3 desktop. See how it looks. Should already have all the dependencies that it needs. They should be available. It detected my FFmpeg even though I built a brand new one. That's awesome. Alright, I'm gonna go ahead and start this build. This build is gonna take a little while. I'm actually gonna take this opportunity to have a little break, and yeah, then we'll check out MPlayer on the PS3 and watch some PS3 videos. Shit, my SPUs are going nuts. Whatever this thing is that I just built, it's going crazy. I set it to create 1,000,000 generations. It's something called the game of life. Uh-oh, frame buffer test. I wonder what that is. I wonder if anybody will be online. Get an online game going. Hey, somebody's playing. Haha. Let's go get my ass kicked, shall we? Oh, I can't play with them. I don't have the right maps. Shit. Boo. Boo hiss. Yeah.
The Americans regrouped at an abandoned bus depot in southeast York. Under the command of a Captain Winters, they staged a daring tactical offensive. The Chimera had begun to close in on their position. If the Americans could secure the site, they would have a perfect landing zone, and the battle would tip in their favor.
Defensive positions. Swain, run a sweep on the north and east walls. Blair, give me south and west. I want to know what's heading this way before we're gagging on it.
Ah, crap. No, that didn't fix it. Shit.
Nicholson, secure that wall. It will take your squad and back him up.
Oh, I'm so dead. Shit, I need help. I'm gonna die.
That stopped him. North wall secure, sir. That's it. We're not going to leave the armor anything but scraps and a bad smell.
Well, I guess it's not running. You know, it's still running bad, but not as bad as it was.
Hostiles to the west. They're coming around that fuel station. Wake up, ladies. We got more company.
Oh, there's some health. Give me that. That's what I need.
Hostile at the fuel station. 9 o'clock. Hands up.
Oh, no good. You know what it is? There's too many people on the screen. Too many units to control. Ah, well. If I get away from the action, maybe it'll work, and maybe it'll move better. Yeah. No, it's no good. Wonder if this is gonna freeze up on me again, like it did in my last stream. Is it playing? Did it start? Oh, there it goes. Oh, no, that's not working. Let's try that one more time. Don't look like that's working. Um, I wonder. Wonder if Bioshock will run. I haven't played this in a while. I don't even remember where I am. Hardly. Yeah. Yeah, well, I tried playing Uncharted, but it doesn't seem to want to stream from my other computer, so... Oh, now it's asking me to... Oh, that's why it wasn't working. I had to put in a code. Well, I'll put it in later. I wanted to check out... it's been a while since I played Bioshock Infinite. I can't really remember what part I'm at, but maybe I'll get back into it. Yeah, I always have a lot of fun when I play this game. I haven't beat it. I haven't beaten it yet. I found the girl. I've gotten that far. Oh, that's weird. That's so weird. I don't have a saved game here. I guess I don't. I guess I got to start over. I thought I'd have a saved game. Whoopsie. Don't laugh. I play this shit on easy. Hey, Chef. You have a good night. Thanks for hanging out.
Booker, are you afraid of God?
No. But I'm afraid of you.
Are you going to just sit there?
As compared to what? Standing?
Not standing, rowing.
Rowing? Haven't planned on it.
So you expect me to shoulder the burden?
No. But I do expect you to do all the rowing.
And why is that?
Coming here was your idea.
My idea?
I've made it very clear that I don't believe in the exercise.
The rowing?
No. Imagine that's wonderful exercise.
Then what?
The entire thought experiment.
Excuse me. How much longer? One goes into an experiment knowing one could fail.
One does not undertake an experiment knowing one has failed.
Can we get back to the rowing?
I suggest you do. We're never going to get there.
No, I mean, I'd greatly appreciate it if you would assist.
Perhaps you should ask him. I imagine he has a greater interest in getting there than I do.
I suppose he does, but there's no point in asking.
Why not?
Because he doesn't row.
He doesn't row.
No, he doesn't row.
Ah, I see what you mean. We've arrived. He's not moving.
He will, eventually.
Suppose he does. Shall we tell him when we'll be returning?
Would that change anything?
It might give him some comfort.
At least that's something we can agree on.
Hey! Somebody meeting me here?
I'd certainly hope so.
It does seem like a dreadful place to be stranded.
Well, maybe there's someone inside.
This is a fucking good-looking game. I wonder how old it is. How many years old it is. I think it holds up. At least it's running good.
Excuse me. It's Booker DeWitt. I guess you're expecting me?
Good luck with that, pal.
Is anyone here? Hello?
Shit. Wait a minute, that card. expect me to sit in their fancy chair.
Make yourself ready, Pilgrim.
Oh.
The bindings are there as a safeguard.
No, no, God damn it!
Ascension. Ascension in the count of 5. Count of 4.
No.
3, 2, 1.
No!
Ascension. Ascension.
Just say, come on.
5,000 feet. 10,000 feet. 15,000 feet. Hallelujah.
Love the prophet because he loves the sinner. Love the sinner because he is you. Without the sinner, what need is there for a redeemer? Without sin, what grace has forgiveness?
Gotta find the exit out of this place.
Excuse me. Where am I?
Heaven, friend. Or as close as we'll see till Judgment Day.
Best keep such questions to myself, unless I want to get made.
And every year, on this day of days, we recommit ourselves to our city and to our prophet, Father Comstock. We recommit through sacrifice and the giving of thanks, and by submerging ourselves in the sweet waters of baptism. And lo, if the prophet has struck down our enemies at noonday, is it someone new? Someone from the Sodom below, newly come to Columbia to be watered clean before our prophet, our founders, and our Lord?
I just need passage into the city.
Passage to the city. Brother, the only way to Columbia is through rebirth in the sweet waters of baptism. Will you be cleansed, brother?
It's either this or turn around and get back on that rocket.
Hey, I baptize you in the name of our prophet, in the name of our founders, and the name of our Lord. I don't know, brothers and sisters, but this one doesn't look clean to me.
Who's there? Who's there?
Bring us the girl and wipe away the debt.
What do you want?
We had a deal to it. Open this door right now.
I told you. I'm not gonna do it. Go away.
Mr. DeWitt! Mr. DeWitt!
That idiot priest needs to learn the difference between baptizing a man and drowning one. I need to find a landmark and figure out where the hell I am.
Above all other nations.
To Father Franklin, a key of gold so that Eden might have industry that set her above all other nations.
To Father Jefferson, a scroll, so that Eden might have laws.
Our prophet fills our lungs with water, so they may better love the air.
He who crossed the Delaware, with flaming sword and wings of angels, watch over me and lend me strength. Shield my mind from fear and doubt, so that I may hold fast
a rebel against ignorance and tyranny. Share with me your wisdom
By the sword
And the scroll. And the key.
Amen.
chance nor luck, only providence. And that you see its divine hand at work.
Just because the city flies don't mean it ain't got its fair share of fools. All right. Still got a girl to find.
I know, Mr. Rossmule. I've never had an oyster.
I bet we could have something great.
Terrible.
Morning. Good to see you.
Perfect day for the celebration.
Father Comstock must have foreseen.
On the holy forgiveness of our dear Lady Comstock, our beloved Mother of Forgiveness.
That statue, I just think it fails to capture Father Comstock's
Oh, their faces look kind of weird.
divinity.
This is a pretty old game. Remember, I did want to test out MPlayer after you know, once I got it installed. So let's take a look at that. Oh, you know what? Forgot I ran that stupid frame buffer test thing and it turned my screen pink. I think I have to reboot my PS3, so let me just go ahead and do that. See what we got here. Wow, I haven't used MPlayer in a very long time. Wow. Look how hard my CPU is working right now. Maybe I should shut the game down for a minute. Let's see what videos I copied over. Wonder if this one will play. This is a sad video.
So today's March 31st, 2010. Turned on my PlayStation and I wasn't able to sign in. I was brought up with this message: you have to update before you sign in. Now mind you, I have an original PlayStation 3 from launch, original 20 gig fat PS3, put a 500 gig hard drive in it, have an other operating system installed on it. I have my PlayStation 3 OS, and whenever I like to, I could switch to Linux. I have Yellow Dog Linux installed on it. I have installed Ubuntu and Ubuntu. I didn't really like them, but I stuck with Yellow Dog. So I also use my PlayStation as a computer. Not very often, but if I want to, I could. I like that option. That was a big selling point. They promised to have that when I first launched. And what does this update do now? Turn on a PlayStation 3, bam, you have to update to log online. This update disables that option. So you can no longer run or install another operating system on the fat PlayStation 3. It's not that I really want to go into that other operating system, is that they're taking away a feature from me. And a feature I originally really wanted. And they're making you take it away because you can't really go online without updating your system. Laren, man, this just proves another one of your points if you're listening to this, man. They got you by the balls, and we shouldn't be able to take this shit. It's a real piss off. I'd like you guys to leave your comments below. What do you think of these actions? What do you think? Should we really be putting up with this? I mean, is it our system? Are we the gamers that? I mean, I guess it's because I'm a big geek and I like to have options and nerdy shit like that. But to the average gamer, they wouldn't care. For me, I do. So there you go. Now I have just a fat PlayStation 3. Leave your comments below. Let me know what you think.
Oh, hey Proxer, how's it going?
Turn back to me real quick.
I just built a video player for my PS3. I built a M player video player, so I'm testing it out. Oh, Pizza Hut. That sounds good.
I'm Kai Stotz. I'm the co-founder and CEO of TerraSoft Solutions. Unlike previous versions of the PlayStation or other game boxes, the PlayStation was designed to be a home computer as well. And in addition to the Game OS, you can also run an entire Linux operating system. So last year, Sony contracted our company to develop a version of Yellow Dog Linux, which is our product, for the PlayStation 3, and that's what we're running here today. It's unique because the PlayStation can now be, for an independent, for a home user, it can be a movie player, an MP3 player. You can watch your home videos on it. You can also play games, and now it's your home computer as well. So we have over 2,000 applications that ship on our single install DVD. Everything from web browsers to your Open Office, which is a Microsoft Office compatible suite, web browsers, email clients, game, pretty much everything you need. Basically, you got a web browser. This is Firefox, which is a very famous open source web browser, and we've got a little thing running in the background that tells you about how the CPU is doing, all different applications that are running. A little bit more geek oriented, but it's kind of fun to look at how things. We've got game running. Game is your instant messenger, and we've got a lot of applications, accessories, games, graphics, internet programs, office suites, programming tools. And what's really nice about the PlayStation is that it's the same processor that's inside some of the really high-end IBM systems. So you can use the PlayStation as a development box and also as a front end to larger performance supercomputing systems that are built on the cell processor. So it serves a dual function for home users or for hardcore developers. It has some limitations in terms of the amount of RAM, but it's not really an issue with Linux for your general desktop environment because Linux is just so efficient. In terms of the multiple cores, having 9 cores on a single CPU is absolutely incredible. And when you optimize your applications for those cores, we're seeing incredible performance. There's an open source product called Mesa, and it's a graphics library, and in 4 days we ported Mesa to the cell processor, and it's now running 80 times faster than the Intel Woodcrest. We've been shipping since November. We've had tens of thousands of users already running it. It's available for free from our website. It's available through resellers. It's also available from our store. We sell the DVD. If you don't want to download it, you just want to get the DVD in the mail. So when you power on the PlayStation, you have a choice. You can either run the Game OS to run your games, or you can choose Linux. And you can just boot back and forth. So every time you boot, you have a choice of which one you want to run. And both of them are running native on the hardware. So it's actually running the full operating system. It's not an emulation. Sony actually designed it to do this. So the Game OS has a partitioning tool, and it actually lets you repartition your hard drive so you can have both operating systems. They don't overlap. So it's really nice. It works very well. Plenty of room. Yellow Dog, the basic installation that we conduct by default is less than 2 gigabytes, so it's not that much space. So even if you only have the 20 gigabyte drive and you use the Game OS to partition it 50-50, there's still plenty of room. And if you get the 60 gigabyte drive, there's still plenty of room. And we've heard about people online installing 250 gigabyte drives in their PlayStation, so already there's some pretty amazing expansion opportunities. The question is really about whether or not there is accelerated graphics capabilities with the GPU. And the NVIDIA chip right now, we do not have access to it, so we're running everything in frame buffer. When that is available, we're working hard to make that available, then there'll be an opportunity to run truly accelerated 3D games, and that'll open up a whole new ballgame of what you can do under Linux, bringing the gamers back to Linux on the PlayStation, giving them the diversity of both Game OS and Linux for high-performance games. We're trying hard. And it's been fantastic to open up this possibility for people. Honestly, I've never been to a show that's so Windows-centric. In our world, everything's Linux, and so it's been fun to show people what Linux is about, and actually, some of these people had never used Linux before, which surprised me. So it's been fun to open up that door and get a whole new user base excited about Linux on the PlayStation.
Oh yeah, during the recession, like the, which one? The 2008, right? Yeah, times was tough. Hey, Proxer. Um, yeah, yeah. Actually, I do have a Discord server. If you check, look in the look in the description for this stream. Should be there. Uh, yeah, here. There's a website here. Yeah, try that. That should work. Yeah, it looks like I've got a little bit more math I've got to look into here. I've got to study up on. Well, I'm gonna get me some more coffee. And I don't know. I think at this point I gotta say I think we did okay for tonight. I got a few more upgrades built on my Fedora 12 installation, and my little cell tutorial project is coming along pretty nice. Under here, PS3 cell tutorial. Watch my GitHub, because I think I'm gonna post this onto my GitHub, and you know, with all of my own special improvements, my own, you know, like bug fixes. So yeah, I'm gonna get me some more coffee, and then maybe catch some news before bed. Yeah, I actually have several distros on my PS3. Yeah, I've got I'm logged into Fedora 12 at the moment. I've also got a Fedora 28 partition, and I've got another one that runs Gen 2, which is you know, bleeding edge. It's totally modern. And there's some other distros that like we've been able to get working as well on the PS3. At least you know, we've been able to get booting. One of the things that I'm actually in the process of is I'm trying to package my own kind of like PS3 compatible stage 3 archive of Fedora 28, or a Fedora 28 like based like respin, I guess, for the PS3. It's one of the things I'm working on. Yeah, I can show you my desktop at the moment. Yeah, this is my PS3 right here. That's an old version of GNOME that the desktop that I'm running. That's GNOME back when that was before GNOME 3 basically, is this desktop. But yeah, normally when I'm running Fedora 12, that means I'm studying the cell CPU, because this is where all the development tools are easy to install. They're compatible with Fedora 12. You know, that's the biggest reason why I keep it here, because it makes it easy to study the CPU. So it's one of the things that I like to do on stream. Anyway, yeah, it's getting pretty late for me, I guess, and it's gonna be past my bedtime soon. So I'm gonna go ahead and shut it down. If anybody's still watching, thanks for hanging out. Don't forget to subscribe if you haven't done that. And I'll see you guys again real soon. Oh my goodness, do I have 31 viewers? Right now? At this moment? That's another record for me. Wow, thanks everybody for showing up. All right, I'll talk to you later.